What are neural networks? Neural networks combine computer science and statistics to find solutions to common AI issues by attempting to mimic the human brain. Deep learning techniques are based on neural networks, which are a subset of machine learning, and are also known as artificial neural networks or simulated neural networks. They mirror the way that organic neurons communicate with one another by taking their name and structure from the human brain. A node layer, which includes an input layer, one or more hidden layers, and an output layer, makes up artificial neural networks. Each node, or artificial neuron, is connected to others and has a weight and threshold that go along with it. Any node whose output exceeds the defined threshold value is activated and begins providing data to the network's uppermost layer. Otherwise, no data is transmitted to the network's next tier. Training data is essential for neural networks to develop and enhance their accuracy over time. However, these learning algorithms become effective tools in computer science and artificial intelligence once they're adjusted for accuracy, enabling us to quickly classify and cluster data. When compared to manual identification by human experts, tasks in speech recognition or picture recognition can be completed in minutes, as opposed to hours. Google's search algorithm uses a neural network, one of the most well-known ones. Why neural networks are important? An artificial intelligence technique called a neural network instructs computers to analyze data in a manner modeled after the human brain. Deep learning is a sort of machine learning that employs interconnected neurons or nodes in a layered framework to mimic the human brain. It develops an adaptive system that computers utilize to continuously learn from their errors and improve. Artificial neural networks so make an effort to tackle complex issues, such as summarizing documents or identifying faces. Computers can make intelligent decisions with minimal human intervention, thanks to neural networks. This is why they can learn and model complex nonlinear relationships between input and output data. Before we continue, subscribe to our channel and press the notification button for more updates. What are neural networks used for? Numerous sectors employ neural networks in various ways. By categorizing medical images, they're utilized in medical diagnosis, targeted marketing, social network filtering, behavioral data analysis, financial forecasting, forecasting electrical load and energy consumption, process and quality assurance, and chemical component identification. What are the types of neural networks? By analyzing the way that information moves from the input node to the output node, artificial neural networks can be categorized. Data is processed in one direction, from the input node to the output node, by feed-forward neural networks. Each node in one layer is linked to each node in the layer above it. To make better predictions over time, a feed-forward network employs a feedback process. Then there is the backpropagation algorithm. Artificial neural networks use corrective feedback loops to continuously learn and enhance their predictive modeling. You can think of the data flowing through the neural network's numerous channels as it moves from the input node to the output node. In order to translate the input node to the right output node, only one path can be considered proper. The neural network employs a feedback loop to discover this path. Each node along the path makes an educated prediction as to what node will come next. It verifies whether the guess was accurate. Node pathways that result in more accurate guesses are given greater weight values, whereas those that result in inaccurate guesses are given lower weight values. There are convolutional neural networks. In convolutional neural networks, the hidden layers carry out convolutions, which are specialized mathematical operations, like filtering or summarizing. They can extract pertinent elements from images that are helpful for image recognition and classification, making them particularly valuable for image classification. Without sacrificing elements that are essential for producing an accurate prediction, the new form is simpler to process. Edges, color, and depth are just a few of the various image properties that each buried layer extracts and analyzes. What are the applications of neural networks? There are many important applications of neural networks in this advanced era, such as computer vision. The ability of computers to gather data and insights from pictures and movies is known as computer vision. Computers can differentiate and recognize images that resemble humans using neural networks. There are many uses for computer vision, including visual recognition in self-driving cars, so they can recognize traffic signs and other road users. Content moderation to automatically delete harmful or objectionable content from image and video archives. Facial recognition to identify faces and recognize features like open eyes, glasses, and facial hair, and image labeling to identify brand logos, clothing, safety gear, and other images. Speech recognition is an additional crucial application. Despite variable speech patterns, pitch, tone, language, and accent, neural networks can analyze human speech. Speech recognition is used by virtual assistants like Amazon Alexa and automatic transcription software to perform tasks like helping call center agents and automatically classifying calls, documenting clinical conversations in real time, and accurately subtitling videos and meeting recordings for a wider audience. Natural language processing is another use. Processing naturally occurring text written by humans is what it is. Computers use neural networks to extract information and meaning from text-based texts and data. It can be used for a variety of tasks, such as creating automated virtual assistants and chatbots, organizing and classifying written data automatically, analyzing business intelligence in lengthy documents like emails and forms, indexing key phrases that indicate sentiment, such as positive and negative comments on social media, summarizing documents, and creating articles for a specific topic. How do neural networks work? Neural network architecture draws its influences from human brain function. To aid in the processing of information, human brain cells known as neurons form a complex, highly interconnected network and communicate with one another via electrical signals. Similar to this, a problem-solving artificial neural network is constructed of artificial neurons. Artificial neural networks are software programs or algorithms that, at their heart, use computing systems to complete mathematical computations. Artificial neurons are software modules, also known as nodes. The input layer, hidden layer, and output layer are the three layers that make up a simple neural network. The input layer is where data from the outside world enters an artificial neural network. Data is processed, analyzed, or categorized by input nodes before being forwarded to the following layer. The input layer, or other hidden layers, serve as the input for hidden layers. It is possible for artificial neural networks to have a lot of hidden layers. Each hidden layer evaluates the output from the preceding layer, refines it, and then sends it to the following layer. The output layer presents the overall outcome of the artificial neural network's data processing. It may include one or more nodes. For instance, if the classification task is binary, the output layer will have a single output node that will indicate whether the outcome is 1 or 0. The output layer might have many output nodes if our classification problem has more than one class though. Millions of artificial neurons are connected in numerous buried layers of deep neural networks, also known as deep learning networks. The links between each node are represented by a weight, which is a number. If one node stimulates another, the weight is positive. If it suppresses the other, it is negative. The influence of a node on other nodes increases as their weight values increase. Deep neural networks may theoretically translate any input type to any output type. In contrast to other machine learning techniques, they also require significantly more training. Instead of the hundreds or thousands of instances that a simpler network could require, they need millions of samples of training data. Contrary to popular belief, neural networks have been around for far longer. Although the concept of a machine that thinks dates back to the ancient Greeks, it was only in recent years that important developments in the field of neural networks, which have fluctuated in prominence over the years, took place. New technologies based on neural networks are continually being developed by researchers. They are particularly effective at handling changes and can adapt because everything is moving towards automation. That's all for today. Hope you found this video informative. Don't forget to like the video, subscribe to our channel, and hit the bell icon. Thanks for watching.